In this third Higher Maths Straight Lines video, we're going to have a look at collinear points and perpendicular lines. Okay, let's look at collinear points first. Now, simply put, points are collinear if they lie on the same line. So A, B and C here are on the same line, so they're collinear. Now, to do that, they need a point in common, and each section of the line, for example, AB and BC, must have the same gradient, because if they've got the same gradient, they are parallel. And if they've got a point in common as well, then they are collinear. Let's do an example. Show that the points A minus 6 minus 5, B 0 minus 3 and C 12 1 are collinear. Now the first step we have to follow is we have to work out the two gradients of the two line sections. So we're going to work out the gradient of AB first, then we're going to calculate the gradient of BC. So if we're looking at the gradient of AB, yeah? So I'm going to look at minus 3 minus 5 over 0 minus 6. Okay, if I work that one out, well, that's minus 3 plus 5, which is 2. 0 minus, so it's plus 6, so it's 2 over 6, which gives me a gradient of 1/3. Okay, we now have to do the same for the gradient of BC. So, gradient of BC. So, 1 minus 3 over 12 minus 0. So if I look at that one, that gives me 4 over 12, which again is 1/3. Right, I can now say, because gradient of AB is equal to the gradient of BC, AB and BC are parallel. Can't leave it there. If I leave it there, I've not proved they're collinear yet. I have to state that they've got a point in common. So, and have point B in common. So, A, B, and C are collinear. So, go through it again. We worked out the gradients of the two line sections, and if they're equal, we can say because the gradient of AB is equal to the gradient of BC, AB and BC are parallel. Then we state they've got a point in common and have point B in common. So A, B and C are collinear. I know it might seem obvious that they've got point B in common, but you must state it if you want to get the marks. Now, if you've got the Hodder-Gibson book, Hodder-Gibson exercise 1.4 is on collinearity. Let's look at the second bit of today's video, and that's perpendicular lines. Perpendicular just means meet at 90 degrees or a right angle. And if two lines with gradients M1 and M2 are perpendicular, then M1 M2 equals minus 1. That is, when you multiply their gradients together, it will give you minus 1. Now, we would normally use that as the following. We'd normally say if we want the perpendicular line, we do minus 1 divided by the gradient of the line we've got. Okay, for example, if M1 was minus 2, then the perpendicular line would be -1 divided by -2, which would be 1/2. Remember, a negative divided by a negative is a positive, and it's 1/2, so 1/2. Leave it as a fraction rather than writing a decimal. We prefer for gradients, fractions, and if necessary, top-heavy fractions rather than mixed numbers. So let's have a look at an example. State the gradient of the line perpendicular to a line with gradient 3. Well, we know what we're doing. We're doing this bit here. So we're doing the perpendicular gradient will be -1 divided by 3, which is just -1/3. Okay? Look at the second one. Okay, so here it's going to be -1 divided by -2/3. Now we know minus divided by a minus, so the answer is going to be positive. And we know if we're dividing by a fraction, we just flip it and multiply, don't we? And if we multiply it by 1, it's just it flipped. So effectively, we changed the sign and flipped the fraction, which is 3/2. Okay? That's our first example. We'll have a look at a more complicated one next. Let's look at this second example. Line AB has equation y equals 1/4 x plus 3. Line CD is perpendicular to AB and passes through 3, 2. Find the equation of this line. Well, first of all, this line is written in y equals mx plus c form, so m1 is going to be 1/4. We know it's the line we're looking for is perpendicular, so m2 -1 divided by 1/4 will just give us -4. Okay? You would normally write -4/1, just write -4. Okay, we want to find the equation of this line. We know that's going to be A, that's going to be B, because that's the point it goes through, 3, 2. So we can use our second bit now, and that's y minus b, which is 2, equals the gradient, which is -4, times x minus, and a is 3. Remember, we can't leave it like that. We're going to have to tidy it up. So y is equal, -2 is equal to multiplying out -4x plus 12. Remember, negative times a negative is a positive. And now we can either write it as y equals -4x, adding 2 to each side, plus 14. Or you could take everything to one side and write 4x plus y minus 14 equals 0. Either would be okay. Okay, so that's perpendicular lines and the end of straight lines video 3. The exercise, if you're using the Hodder-Gibson book, is exercise 1.5 for questions like this.